Hello, everybody. As Kathleen said, my name is Jöran Vinzens. I'm working for a small company in Germany called Sipgate, and I was wondering if anybody know that company already? Oh, that's great. So I don't have to use the company anymore. That's great. So anyhow, we are a VoIP carrier and service provider in Germany. And we are offering services in Germany, but as well in UK, good for all the people who are working or living here. I started working at the Sipgate a couple of years ago. And when I started there, we had a lot of manual work to do. So everything we did was a manual. And this was kind of a nightmare, and yeah, when we grew up and hired lots of more people, we need a change. And then we thought, okay, it might be a good idea to automate all the things. We started with some backend infrastructure, and then we got to our VoIP systems, and all the learnings we did and all the good and the bad things we discovered, we thought it might be a good idea to share that. So back, I would say 4 years ago, our deployment looked like that. This is a deployment of about 40 machines running a small tool called cluster SSH, which basically opens up a window for 40 systems or whatever you have in the background. And then you have one input field and several output fields. And as you can see, you can pretty much see nothing. So you more or less hope you're doing the right thing. So if you, for example, restart the asterisk and you open the console asterisk -rx, whatever, then you more or less hope you opened the asterisk and not that there's any password prompt or some misspelling anywhere you can't see. So this was a nightmare. So we had this manual deployment, and additional to that, we had every 2 weeks a patch day at the end of the sprint, which is difficult if you have a collection of 2 weeks work and deploy it at once, so you don't know if you have a failure, where is the failure located. So you did a lot of work, and maybe 100 people did work, and then something breaks, and you don't know why. We met in the morning with everybody, or at least a couple of people, and we published everything we did into our production system. And the rest of the day was more or less manual testing. Then, as we usually forgot something, we had to deploy something later on because this is a voicemail, we need to deploy the voicemail as well. This leads to a different code base in our development to our production platform, since we just developed on-site on the development machines and then pushed everything at one time to the production system, but only what we knew we had done. So if we forget something in the development, it was not checked in, it was not in our GitHub, so we can push it to in production. So we needed a change there, and we found it in Ansible. Ansible is a magic tool for configuration deployment and system deployment. We started with our business backend logic, which is mainly written in Java and Perl, unfortunately. But it was the biggest pain we had because the development community was the biggest in the company. And after that, we ported some front-end websites to Ansible as well, that they can be pushed by anybody into production. And after that, we started, after the learnings we had made with our VoIP infrastructure. The newest thing we've done is even our network infrastructure, which is based on an open source system, moved from the Cisco config-like style to Ansible. So we configure each port with Ansible, which is pretty great. But the initial idea behind that, we want to have continuous deployment and continuous integration for sure. There should be no need to know the setup or the entire setup. You should know your web server, or you should know your Java backend, or you should know your kamailio for sure. But you don't need to know on which system this is running. If there's a load balancer, you have to switch off, switch on, whatever. And then we wanted to enable everybody to make changes, and not only the maintainer. And to ensure quality, we want to have automatic tests, and if anything fails or crashes, we want to have an automatic rollback. So this all leads to a secure rollout, so where we have the insurance, I would say, that we push the button that everything is working or failing and gets rolled out to the latest state which were working. This was the initial idea. There are several components involved in our setup, which is in the first place GitHub. We have GitHub Enterprise, where we have all of our configuration and our code, nearly all. Then we have Jenkins doing all the jobs. Then we have Ansible doing all the magic. And then we have Debian as basis of everything else. So we use Debian systems. So far it's mainly bare metal, some virtual machines, and we are just scratching on this Docker hype. I know we are late, but yeah, it's coming up. So how does it work? The initial idea was, we have a couple of people coding or changing websites, or for example, our HR compartment makes a new offering for a job. They just push it to the website, and then it gets deployed automatically. So anyhow, the code gets pushed to our GitHub, and there's a GitHub trigger to Jenkins, so Jenkins knows, oh, there is a change, I need to do something. And in the first place, GitHub packs everything together in a Debian package. So we have a version of that configuration or that code, whatever. And after that, GitHub triggers Ansible to doing some magic. And in the first place, Ansible checks the already installed version of that change, whatever, on the system. And after that, we install the new version of that system, or that package, that config, whatever. And we install the configuration that it's working. We reload the systems, or we get the systems which are down again, back in the routing again. We make some smoke test, integration test, whatever. And if anything fails, we roll back to the old package we have installed. We know it's working. So that was the initial idea. With Ansible, you have several things coming together in there. We have lots of templates, we have files we can just copy, we have environment data, which is by magic or by configuration there. And all of this is used to put everything on the machines where you want to have your service on. But VoIP is not an average service, so VoIP has special needs. For example, restarting of an asterisk during running. So you have calls. If you just restart the service to have a new zipconf in place or a new, extension conf in place, you just crash some calls. You have real-time communications, so you just can't put a lot of work on a system which is then overloading and not doing routing or media switching anymore. You have ongoing session, for example, in the kamailio, so you can't just restart the kamailio. You have retransmits if you have downtimes. I imagine if you have a couple of users or some thousands of users and you switch off your system, then you get hit by a flood of retransmits or register or invites, whatever, from your customer when you switch on the system again. So you have to deal with that. Then you have UDP, TCP, SCTP services, so you can't just have a TCP proxy and everything's fine. You have load balancers like kamailio or FreeSwitch, whatever, OpenShips in front you can manage, so you can get your system out of routing, then it's easier to deploy. And then you have big config files. I assume when we started, we had a kamailio instance, which is a stateful proxy with us. The configuration file has something about 3,500 lines. So this is big. And as well, we have lots of different systems, so it's not an Apache just 30 times. It's, in our case, it's a kamailio, it's an asterisk, it's a yate, it's Zipwise RTP engine. And all of these components has to be treated in a different way. So we just can't have this one standard model and everything's working. So you have to know the systems I configure now or install now is a kamailio, and I can restart it or I cannot restart it depending if it's a stateful proxy or stateless load balancer, whatever. So you need to know a little bit about your system while creating your Ansible or creating your deployment, but not while rolling out the config or the system. So what we did in the first place is we did several iterations. We have lots of systems, different systems, as I said, and as well we did a lot of mistakes. So mainly we did bullshit. So we learned from that and changed that and made it better. And I would say we made a lot of learnings. So it sounds nicer. So the best way we know so far for our systems is to pack code in Debian packages and install the Debian packages by Debian aptitude or whatever, and create the config by Ansible. So only the part which is definitely config needs to be dependent on the system itself. So for this we have to separate the code from the config, but that's not that easy like it sounds. I would say code like config is code. Let's take, for example, the extensions conf or the kamailio conf, the routing sections. You have, like an if, you have a loop, you have variables you save. This is pretty much like a Java code, just in another language. But as well, you have, for example, in the kamailio, you have the header part where you have an ini-style configuration. So it's not that easy. What we would say is like AMI, AGI, or ARI scripts that are code for sure. Then we have, for example, the kamailio using Kimi, which is definitely code. And then you have, for example, for yate, we have some modules which are PHP or Python. They are code as well. Why did we do that? In the first place, to match the initial idea of our rollout system. We put the code into packages to enable the rollback of the logic changes we do. For example, we change how a call from a customer is treated. This we want to have in development and in production the same. So this is agnostic to the environment. So this is code, I would say. And if we have this in this package, we can roll out the package and make sure we have a version which worked before. So this rollback is important for us. Then we keep the config simple. So if we separate the config part from the kamailio from the root part in the kamailio, we have a very short config file. Then for sure, if we split it, we have a track of the logic changes we did. So we have an own GitHub repository just for the logic routing section in the kamailio. So everything we do in changing the routing engine, we have a commit message. I changed that because this customer made something and we found this bug, for example. Question?
You say you package the source code into a Debian package.
Yeah.
Because there are often scripts which can be interpreted, or you also have Java code which needs to compile. Needs to compile first.
Yeah. The question is, we have code like Java code. And we have code which does not need to be compiled like Python or kamailio config or asterisk extensions conf, and we treat that the same. It doesn't matter. It's for the Java code or for the C code we have, we just have to compile it before, but the packaging is the same. So at the end we get a Debian package where we have this snippet or this jar or whatever in there. So. And then, as I said, we have, if we do that, if we do keep the config or the code where we have the routing decisions separated from the config, we definitely make sure that development and production is the same. So I install the version of my code on the development version and it's working, and I install it on the production system with another config because of listen IP address, whatever. And I definitely know it's the same, so it should behave the same. this is how it might look. So we have a config part in the kamailio, which is some ini style stuff like debug, if it is able to fork, standard log, whatever. And then we have this code section where we had the root or the main root, the different other roots we can have, on reply root, whatever. So this is pretty easy to cut there, except we have this. This is a code snippet where we have in a root section, we check for an IP address. These things are a nightmare because you have environment variable in the code block. But I figured no point where we didn't find any solution, and in this case we can use the pseudo variable module to put that in the config section and use the variable in the routing section, so we can defer that. We had the same with this standard output interface. There's a variable for that too, so you can use the force send socket with an IP address, or you can use the usocket variable for that. So this is pretty easy. And it's working for us. And with 3,500 lines of code, I would say we have a lot to figure out. So how does it come together? Now we have a Debian package and an ini file style config, and yeah, I have it on my PC, so what then? Only the kamailio config from the Debian package and the Ansible config part together makes a running configuration. And kamailio, as like asterisk and yate, does bring a solution for that. You can just include a file. So it doesn't matter what file you include in what file. So in this case, I included the config section in the Debian package. So you have at the end, if the kamailio is started, they pass all the files you need. So you can even split up your, for example, your mod param section in single files. You can put your routing section in one file and the reply route in another file, and then have maybe a single file for all the inclusions. Might be possible. Gets a little bit, distracting, I would say, or not that easy to maintain. But in this case, we have just a config section, and this gets included in the main kamailio config, so it gets at all running configuration. So what's possible with Ansible? Now we have a running configuration, but we don't know how it's get to the system. And on a sample on the asterisk, I can show you how Ansible get it all together. In the first place, in Ansible, we have groups called host groups. It's pretty easy. And in this inventory of host groups, we have different hosts. And it's called inventory because it's the inventory of our company, whatever. And we give it a name, and this name can we use later on. So we have different hosts in one host group, and in our playbook, so-called, because it's we want to play all the roles, we can say, okay, this playbook should be deployed on hosts, or on single hosts, or on a host group. In this case, you can see we want to have this playbook, asterisk YAML, deployed on the host group asterisk. And in the host group asterisk, we have host 1, 2, 3. So it's pretty easy. And after that, we can say, okay, you should go with SSH on the system. You should become root, and please just one at a time. And please do following roles. Here you can make a logic decision which role makes sense in which step. Maybe you want to have everything in one role. Maybe you want to split that up. It's just on you how you do it, how it makes sense. What you can use during this run of the playbook, you can use the group vars, which are bind to the group. So every host in the group has the same value for maybe a zip port. All the asterisks should have 5060 as default zip port. This is pretty easy. Then we have the host vars, which are depending on the host. For example, the listen IP address would be a nightmare if this is a host var and all the asterisk instances get the same IP address. Doesn't work, and the asterisk complaining about that. But so here we have the host was depending on the host. And then we have the so-called Ansible effects. When Ansible starts, it touches the system and gets a list of lots of variables. For example, the IPv4 or v6 standard IP address. So you can use it later on in your playbook, or the host name or whatever. So with all of that, you can modify or make it more variable for your config files. The group vars, the host vars, and the Ansible effects are collected before the playbook starts, actually. And then with all these variables in place, they go over all the hosts. So the host vars for sure change in the middle, depending on the host. But you can actually use them during your playbook. In Ansible, there are many things you can do, like copy, or you can use a template, you can execute a command or shell. You can place a file, you can use a service module, you can use apt, for example, on Debian, or RPM on CentOS or any other RPM-based system. You can use fail, which is quite handy, I would say. And for example, you can use MySQL stuff. There's much more, but I just give a look on these ones, not on all this. So if you need more, you can go to the Ansible documentation, which is pretty good. For example, copy. In this case, this is one task to perform during a playbook. We have this in these double brackets, the variable host name, which comes from the Ansible effects. So if I have a file called host1example.com _sipconf, Ansible takes this file and copies that on the remote system in etc *sipconf. So I have a kind of variable thinking in that. For sipconf, it might not be that clever to use file for that, because we have something like template. There we can modify the content of the file as well. So just not just the name of the file, just the content. The templates are written according the Jinja 2 templating format. So there are loops, there are replacements, there are conditions. You can do everything in the file. But to keep it easy, we have here the zip port and service port and service IP, which we get from the Ansible environment. So the host vars and the group vars and the Ansible effects. And we want to have this sipconf template put on the remote system in sipconf A, because the box was too small, asterisk sipconf, whatever. During the playbook runs, it takes from the group vars the service port 5060 and the service IP, depending on the host, and put that into the sipconf and places that on the system. So we have at the end, we have on each and every system an independent or different sipconf, especially for that system, but at the end, pretty similar each. Then we have, which is just for the asterisk or something else, it's very handy, for example, the command or shell. Command is command, what you can run on the remote system. For example, if you want to reload the dial plan, you can do that. Ansible doesn't know about asterisk, so it just doesn't care about. So you can just call the asterisk remote console, dial plan reload, and the dial plan gets reloaded. Same for zip reload as example. And then you have shell, which is pretty much the same, but you get a shell and not a command. So you can use the shell pipes or forwardings of the output. For example, I did here an echo date forwarded to /temp/last rollout. So if I jump on the system, I can check when the last rollout was, just for example. There are some much more complex scenarios I have here I can show you. Then there's something what you want to do in a normal basis. You have normally a task after task performing on the remote machine, but there are some possibilities to perform tasks on other hosts. So you have your group of hosts in the asterisk environment group, host 1, 2, 3. But for example, you want to disable the asterisk on the dispatcher in the kamailio first, but this is running on another host. How do you get there? Therefore, we have this delegate to. So this is performing a task on another host, but with the same variables from the one host. In this case, we can use the kamailio command module to set the dispatcher set for this specific service IP port combination to down, so it does not get new calls. So it runs empty eventually. So this enables us to first get the system out of the routing, do stuff, get it in again. And if anything crashes in the meantime, the entire play fails, and we can fix it. That's manually, mostly. Then there are things you can do with MySQL, for example, or any other SQL database. For example, if your system with an AGI or MRI or whatever script needs to go to a database, and you don't care about database users anymore, you can use a MySQL module to actually create a user on the MySQL database in order the users can access the MySQL database. Here again, we use the MySQL task to perform something on a MySQL database, and we delegate it to the MySQL database because it's not running on the asterisk. Then, yeah, we have a user on the database, but we don't know if it's work. So we can check the config if it's working. In this case, for example, here we make a shell command. We echo select 1, so we just wanted to have a 1 back, and we pipe it through MySQL with the user credentials we just had to create the user, and we register the outcome from the standard output of the MySQL command. And then we fail if we don't identify a 1 there, because we should get a 1 there. If we get connection refused, whatever, it fails. So we want to know that, oh, fuck, I forgot the firewall, for example, something like that. Or I don't know, I have a mistake in my password, or I just want to have a connection to another database and I didn't figure it out, for example. You can do that all in one playbook. You have a question?
Yes. So when this MySQL module, is that running on the machine you're installing on, or is it running on the machine you're running Ansible on?
This MySQL, in this case, the MySQL user command is running on the given machine. In this case, we delegate this task to another machine. So this is running on the DB host locally.
Okay, so you're not having to have access to the production
No.
database from the machine you're launching Ansible from?
No, you SSH to the machine. So I repeat the question for the video. If the MySQL user task is performed on my local machine where I run the playbook, or if it's somewhere else. The answer is it's performed there where it should be. In this case, we have this delegate to, which is getting my SSH to my DB host, where it's performed locally. So it makes locally a DB connection on the machine itself. So I don't need to expose MySQL super writes throughout the network. I just have to have SSH connection possibilities. And then we have something, right? It's. I did a lot of time this wrong. So here we write the dispatcher for a specific host to a database. This is if you use the dispatcher module in kamailio or some other things, I don't know, you can automatically put that in the right dispatcher group and reload the dispatcher afterwards, so it gets traffic automatically. In this case, you have a bit quoting issues and a little bit breaking issues, so you have to get through that. But at the end, it's possible to make this insert into dispatcher, for example, into the database, so your asterisk gets traffic. And then for sure we need to reload our dispatcher, that it gets the new information from the database. Just come CMD again, just dispatcher reload. And then we can check if the actual dispatcher set is as we want it to have. So it should be active probing. And if it's not active probing, we want to fail. So we do that here, this dispatcher list command, that we get JSON looking output, which is not JSON. This makes it a little bit hard. And then we check if there is an IP string, which is not an IP. It stands for inactive probing. So the host we just deployed is inactive in the dispatcher set. And we want to know that maybe it's the same like the select one. We want to know if it's not connecting to each other. And then we fail again. But we know. Then we have learned a lot. And when I get asked, how should I implement that? I always answer, start where you are. So you already doing manual steps, you can just automate them. We have Jenkins, GitHub triggers, build pipelines, whatever. You don't need them. You just need this Ansible playbook command. You need to have an inventory where all your groups and hosts are listed, and then you have your YAML file which defines what tasks should be performed. So for example, you SSH to your server, you pull a Git repository, you copy some files, you trigger script and reload the service at the end, for example. It's the most basic thing you can do. It looked like something like that. The first, we see if a path is absent. So if there is a folder in temp/config, it just gets deleted. And no matter if there is some folders under there, it just gets thrown away. Then we have this command where we get this git clone. So we clone a remote repository to this temp folder, and then we have the script which maybe installed the config files we want to have. We already do, and then we see if the config part we just cloned there gets deleted and again, because maybe we don't want to have the old config or the Git repository on the system, and then we restart the service, for example. This is the most basic thing you can do. And it's just, written in the same time you do it manually. We have some lessons learned. First of all, avoid non-testable stuff. You can't test really good the extensions conf or kamailio conf. You can't, just can't. You can make integration tests. You can make test calls. You can, maybe if you have a kamailio, you can place maybe 5,000 test calls and you don't cover everything. So it's a nightmare. So avoid it. You have the possibilities of ARI, MGI, AGI, and all the other scripts in asterisk. And you have the possibility, for example, the kamailio module in the kamailio. And we just recently made a project where we used a project we did was totally based on Lua as a Kemi instance in kamailio. So we have the entire routing logic in Lua, so we can just test it. Then, for example, make the kamailio restart safe. It's a nightmare to restart a stateful instance. You have the possibility to write your hash table into database that it's get loaded after it starts again. You have the possibility to save your location in the database. You can use distributed message queue to spread out the information through other instances. Avoid dialog tracking so you can easily restart at any moment. Avoid stateful instances so you can restart anytime. So you make your life much more easy. Then coming slowly to the end, I have some numbers and figures. This is a core routing engine we have. It's written in Perl. I think it's started developing 2006 or 2004, something like that. So it's pretty old. But we still use it, and we ported the configuration to Ansible. And here's a snippet of the GitHub repository, how many commits and so. And we had a week where we have 33 commits. Most of them were done by our customer support, which does nothing know about, or nobody knows about Perl anything. They don't need to. They just edit the config file and push it to GitHub or use the web GUI from GitHub Enterprise. We had one day where we had 8 commits a day for routing changes, and every commit goes directly into production. So we know exactly which commit breaks the system at the end. As I said, mostly by customer support, because they have the request for, I can't reach this number, can you please change the routing? So I don't want to do that. They should be able to do that by themselves. For the asterisk, we had a week where we have 21 commits in the asterisk configuration. In the peak, we had 9 commits a day, and nearly every commit goes to production, but every single commit goes to development. So we exactly knew when it breaks, when we are not able to do the testing in the development anymore. Then we have, for example, the kamailio rerun. We have 11 machines, bare metal, and 3 virtual machines running 86 instances of kamailio, and our deployment tool takes 11 minutes to deploy all of them. During that task, or during that playbook, we have 1,111 tasks performed in 11 minutes. I'm not able to do that by hand. No chance. For our asterisk config, we have, in 15 minutes, we have installed on 47 machines the asterisk config, checked if the asterisk config is working, and with smoke test everything. So I can't get this by hand. Then I put that on later on again. We have some documentation and made something open source or public. The first one is we have a blog article about Ansible and our newest network infrastructure change we did. It's the first link. Then the second link is all the samples I showed you just now on the slides. I have put it in our Git repository. There. We have a short link here for the Ansible samples, so you can just download them and just test it. Then there was an Ansible talk of my colleague just introducing before we had it already installed. And then for sure, if you want to use Ansible, you want to have this Ansible documentation link. And last but not least, a colleague of mine, which is here, the tall guy called Sebastian Damm, he did a talk at Kamailio World for test-driven development in Kamailio with Lua. So we can have, or we can make sure we have a working version installed on the live or in the production. Are there any questions? For sure you have questions.
So at the beginning of your presentation, you were talking about also having the ability for rollbacks, but I haven't seen anything in your version about showing a concept of next version, previous version to say, okay, something's bad, go back to previous version of asterisk.
We get this for free from Debian, I would say. So if you push asterisk config Debian repository or Debian package to the repository, it gets a new version stamp. So if you have in your Ansible script install the latest version, then it gets updated automatically. And in the before you do that, you can just remind you which version is already installed, which version of that Debian package is installed. And if it fails, you can just say aptitude install the old package, which is still there.
Okay. But you even have a separate playbook for the downgrading, or?
We have, yeah, but you can do that all in one playbook. I think we run out of time, but we have one more question.
Yeah, I think we got one more.
So you mentioned that you do some checks before restarting Kamailio, for example.
Yeah.
Is that syntax checks? Is that like active dialogues checks, or just syntax?
Yeah, it's just syntax. We install the configuration in the temp folder and make a config check for the Kamailio config. Yeah.
It would be nice to have something more complex, let's say, but yeah, it's probably...
It's difficult. This is why you don't want to have Kamailio config, or in your case, not Kamailio config, but if you do that with Kemi, in Lua, in JavaScript, in whatever you want, you can check in more detail.
No, I was thinking about this before this conference, that's why.
Sure. Yeah, then, thanks.
All right, thank you.